Good afternoon, Tech Nation. Thank you all for participating in today's webinar. We are thrilled with the great turnout today with over 415 attendees registered. A few notes before we begin. Earlier today, registrants were emailed a Webinar Wednesday workbook. If you did not receive a copy, you can download a copy in the handout section of your webinar dashboard. During today's webinar, all lines will be muted, but you can submit questions during the presentation by using the questions or chat feature on your dashboard. Today's webinar is eligible for 1 CE credit from the ACI. To obtain your certificate of attendance, you must complete the post-webinar survey, which will appear immediately on your computer screen at the end of today's call. Certificates will be emailed on or before December 3rd. If you do not receive the survey, please email us at webinar@mdpublishing.com. Don't forget, many of the same speakers and presentations from our Webinar Wednesday series are featured at our annual trade shows. Our next trade show, MD Expo Dallas, will be held April 21 to 23 at the Fairmont Hotel in downtown Dallas. You can learn more about this event by visiting mdexposhow.com. All right, Tech Nation would like to thank today's sponsor, Conquest Imaging. Conquest Imaging is the largest supplier of ultrasound parts, probes, transducers, probe transducer repair, training, service, and free 24/7 technical support. Their exclusive quality assurance 360-degree program ensures that you not only get a part that performs to OEM specifications upon installation, but outlast the competition. Conquest Imaging, because quality matters. For more information, visit conquestimaging.com. We are excited about our presenter today, Mr. Jim Rickner. He's the training director for Conquest Imaging. He has over 20 years experience working on a variety of electrical equipment. His experience includes repairing and operating flight simulators, specialty aircraft avionics, destructive material testing instruments, and a variety of ultrasound systems. He has worked for Conquest for over 9 years and is the senior field service engineer prior to becoming the training director. Jim, you may begin whenever you are ready.
Thank you, John. I want to thank everybody for joining us today. I know we are very busy. We have lots of work out there to do. I think many of us are here today because we share a common goal, and that's that we want to go out and we want to do our jobs. We want to be able to repair our equipment and save our facilities money. Today's environment, many OEMs limit our right to repair, and it makes it very difficult for us to be able to go out and successfully provide prompt service, lower costs, and provide that better patient care that we're all looking for. So today, as we discuss the Epiq, the 5 and 7, the intent is to provide you as healthcare technology professionals some tools that you can use to maximize your uptime, reduce your costs, and provide quality patient care. With that in mind, I think it would be remiss for me to not start this conversation talking about preventative maintenance. This is where an opportunity for you as biomeds, clinical engineers, field service engineers to provide quality for the dollar. So let's get started with preventative maintenance. My philosophy on preventative maintenance is no matter what, the first thing you should do is back up, back up, back up. Without a successful backup, it's really impossible for us to be able to come back and restore a system successfully. And I say this is something you should do during preventative maintenance, but in reality, anytime you step in front of an ultrasound system, this is really something you need to do first thing. As long as your ultrasound system is up and working, your very first step should be backup. An important note when we're talking backups is it's not complete just to throw a disk in the system and burn a copy of your backup. It must include printouts. Why printouts? Printouts possibly, in all likelihood, will contain information that is not stored on a backup. An example of information that may or may not be stored would be the system's TCP/IP address. So if you don't take the time to create this backup, you run the risk of not having the information when you do try to restore the system. So how do you create a backup on the Epiq system? I'll show you in the next slide a picture of the screens I'm trying to describe right now. But As far as there's a support button on the control panel. It's on the right-hand side of the control panel. It's clearly marked support. And as you press that, it'll bring up a image onto your monitor. And one of your tabs will be System Management. And on a sidebar, one of them will say Backup Restore. You simply select the backup function at this point and hit Start, and it creates your backup. I've listed other information, system information. The reason I've listed system information there is this is where I'm talking about you need to get a printout. And many systems, many Epiq systems, for example, don't have printers on them. They don't rely on the black and white printers like they used to. So you can use a picture of this. You can create a study called PM and save this to the PAC system. Whatever mechanism you use, it's important that you get the system information. Additionally, you go to the setups. You exit support and go to setups to the About page, and there will be a screen, and again, you'll see this in the next slide, that lists additional license options, as well as the license transducer for the particular system you're working on. Now, these aren't displayed. You actually have to click on the down arrow on the very right-hand side of the screen to expand the menu, and then you'll be able to see your license options. And make sure you scroll through all of them to get a good picture of them. So on the left-hand side of this slide here, you can see we have gone into the support menu. You see System Management, and you see the Backup Restore button. It's really that simple. Once you go into the Backup Restore function, select Backup and go, and it goes on. On the right-hand side, you can see that we went into the setups, and on the complete right-hand side, you have your license transducers that I've already pulled down for you. Those will not be pulled down as you enter the page. You also have your license options. This tells you what your system's capable of doing. So moving further into preventative maintenance, once you actually start the preventative maintenance, you successfully backed up the system. We want to start by cleaning the air filter. The air filter is located on the lower left-hand side of the system, and it just slides out. It's a very easy filter to get to. You need to make sure to service the brakes and steering lock mechanisms. This is a fairly new system. We haven't had a lot of problems with the brake mechanisms or steering mechanism for that matter, but it's important to understand that this is an accreditation requirement. ACR, for example, requires that you check the functionality of brakes and steering. Check the monitor articulation mechanism. In just a couple minutes, I have some slides that will show you exactly how to perform this if it's not right. In a PM, you're checking it. If it's not adjusted correctly, we will show you a service adjustment on how to do that. Same thing with the control panel articulation. You need to clean the trackball. The trackball is very easy to clean on this. It has a ring that you rotate the ring a quarter of a turn and pop off the ring and get the trackball out. There's no need to remove the control panel or anything else, as in several other systems. You want to clean the monitor and touch screens and clean exterior system surfaces. Another important note when we're talking cleaning, the probes, the monitors, the surfaces, this is another accreditation high point because they consider this to be patient and operator safety because it is a health possibility problem or potential problem. There are several performance tests that OEMs like to list, and all of the OEMs basically recommend that you check every imaging mode. So I've listed some specific checks that we want to make sure you cover during this preventative maintenance. You want to start off by making sure you can create an exam. My recommendation is call it exactly what you're going to do. If you're doing an ACR PM, for example, I put my first name as PM and my last name is ACR, and that indicates exactly what specification you're performing this PM to. You also want to do 2D image testing. as well as going into testing color and color power angio on the cardiac systems. You want to test your pulse wave, continuous wave, and M modes, as well as live 3D, if that option is available. Obviously, not all Epiqs come with the ability to do live 3D. And you want to test connectivity and review. And this is always the last thing I do, because it's the first thing that a customer will call me back on if I do a PM and I bump a wire or I unplug it, whatever I'm doing to clean it or whatever. I will leave the site, and about 20 minutes later I'll get the call, my network's not working. So I pay particular attention to testing my connectivity just prior to leaving for any kind of service. You need to test the annotation and body markers, make sure you have access to them. Measurement and analysis tests, these would be that you have access to calculations. You want to do caliper measurements, your 2 centimeter horizontal, 2 centimeter vertical tests. Query retrieval tests, meaning that you can access the PAC system and retrieve old patient data and bring it back to the ultrasound system. And peripheral tests. On many of the modern ultrasounds, peripherals have mostly gone away because they have the PAC system, they have the reading stations. But if they do have a black and white printer, a color printer, or DVR, make sure you take the time to perform peripheral tests. Now, all these tests I just talked about, they have specific steps that are associated with them, and I wish we had time to go through each one of them. But if you're interested in how to complete these tests, I encourage you, we have a 2-day classes on many of the modern systems that will thoroughly go through how to perform a PM and the tests that are associated with each of these tests that are mandated by OEMs. So let's talk about the service adjustments. I mentioned that you could adjust the articulation arm buoyancy if the monitor won't move down because it has too much buoyancy, or it just falls down because it doesn't have enough. You can remove the left and right articulation arm covers, and I have a video of this on the next slide, so I'm just going to cover it real quick and then we'll go over it on the following slide. On the end closest to the monitor, there's a locking screw and an adjustment screw. You simply unlock or loosen the locking screw and then make the proper adjustments on the adjustment screw, retighten the locking screw, test operation, and if it's all good, replace the covers. And here is the video of how to remove them. There are no screws involved at all on taking the covers off, which makes it kind of nice. So just little clips that you can see there. And both covers come off in a similar manner. And then on the right-hand side, it shows you the locking screw that you just simply loosen, and again make the proper adjustments for the adjustment screw, and you're check the operation, and you should be ready to go, good to go. Another adjustment is if your operator is saying, well, it's really hard to turn my monitor to swivel it. There's an adjustment on that. It's called the swivel knuckle tension adjustment. You can rotate the monitor left and right to see how hard or easy it is, and you just simply need to tighten the screw. And here's a picture of that adjustment screw. You can clearly see the monitor and the swivel mechanism. You simply tighten or loosen it to adjust it appropriately. So now we're going to move into what we call general information. We're going to cover theory of operation, board names, some of the stuff that you'll need to know to accurately or convey a message. I need this board. Well, if you know the name of the board, it'll help us identify it for you. So let's get started. The Epiq has 4 possible power statuses. If there's no light on the power button that you can see there, that means there's just no AC power, or that you're not getting your 5-volt standby, which we will talk about in a future slide. If it is plugged in, but the system has not been powered on. It would be in a standby mode, and you'll see the white light that is indicated in the picture on the right. If it's powered on, and in reality, as soon as you press the power on light, the light will turn from white to green. And then if you have a sleep mode, the sleep mode is the crescent moon button that you see below the power button. This puts it into a sleep mode, and the sleep mode then will cause not the sleep button, not the crescent moon button to blink, but the actual power on button will begin blinking green. There are several boards and the acronyms for them, so I'm not going to go through each one, but I am going to cover several of them because these are the ones that I believe make up the meat of the system. You have your acquisition control board, and we're going to define the functionalities of that. Again, the abbreviation is ACB. You have audio input-output board, channel boards, control panel, display port. You have an extended input-output board, motor control board. Let's mention the motor control board because it's an optional board. That's specifically if the system does have 3D, 4D capability or live 3D. Your motherboard is simply your computer module or your backplane. You have a platform power module. You might see this also abbreviated as VPPM. That's just Voyager Platform Power Module. That's the manufacturer of it. It's used interchangeably, so you might see VPPM instead. You have a power regulator board we'll discuss. This system is unique in that it has a solid-state drive in it, so I want to point that out. Your transducer select board is simply your probe interface board. This is where you plug your probes in. We'll define some of those functions also. Then you have your VDSys, if you see that throughout any kind of notes, or it's just your system DC voltage. And then we'll finish with a video input-output. Again, I'll do some theory on each of those boards that I've discussed or mentioned. So how do you access the E-module? Well, this is kind of a nice system, and they made it very easy. You have to locate the peripheral bay release mechanisms, and I'm going to show you a picture of this mechanism. It's easy to visualize, but it's hard to see unless you're down on the ground looking up. So keep in mind, it's a slide release mechanism. It has just you find the notches that your finger fits in, and you pull it towards the back, this release mechanism towards the back of the system, and you simply lift up the entire peripheral bay and up and back. And you'll see a video of this coming up. And then you have your card cage cover that have two locks on them. These locks you just simply rotate 90 degrees and remove the E-module card cage cover. And here's a video of it. As I said, on the left, you can see the release mechanism, and there's a notch in there for your finger. You just hold it. Something I want to mention is there's one of these release mechanisms on each side of the system, and you may have an external I/O panel that's blocking or hiding the release mechanism on the left-hand side as you face the system from the front. And so you'll need to take a Torx 20 and remove one screw and get that E-module, or I'm sorry, the input-output module out of the way, the external one. It has like a clip. You just take a flathead screwdriver and get the clip out of the way. It pops out, and then you'll have access to the sliding mechanism that will allow you to lift the whole E-module. A caution I have is if they do have peripherals in this, that E-module, the peripheral bay module can get pretty heavy and a little awkward to lift and pull back like that. So be careful on that. This one does not. The video does not have any peripherals in it, so it makes it pretty easy. Here's a graphic that we have for the E-module board layout. On the left-hand side, you have your acquisition control board, and right next to it, the power regulator board. Then you have your 3 hard drives. This is configured much like the 22 and 33 as far as a hard drive configuration goes. Hard drive 0 would be your solid state drive, and we'll get into a little bit more about that, but that's where your operating system and application software lives. And then you have your hard drive 1 and 2, which are just standard hard drives. They're the smaller lap-type versions of hard drives, and they handle patient data and cine loops. You have your motor control board, if it's present, if it has a 3D, 4D option, physio module, and then you have your input-output boards, basically your top one, your audio input-output, then you have your extended input-output, video input-output, and then a graphics card. There are also different motherboards with different processor configurations. The original ones came out with 2 processors, and we'll describe that a little bit, and a newer version came out with a single processor. So you'll have to be aware of which version you're working with. And here's an actual picture of the board layout. Again, on the left-hand side, you have your acquisition control board and your power regulator board. Towards the top, just to the right of those 2 boards, you can see your 3 hard drives, and then you have your I/O boards, your audio, your external, and your video. So the operating system that the Epiq works with is Windows 7 embedded. It basically sets up your system so that it can customize components and system operation. It's mostly used for system interaction with the user or the network. It makes it easy for everybody to use. The OS platform is also the mechanism at which the application is launched. The application is basically what we call it or describe as a shell, meaning it overlays Windows so that we as users don't have direct access to Windows. This causes some problems from a service perspective, but it actually saves us probably some pain because the users don't have access and they don't have the ability to go in and change the settings in the Windows environment. We have our power subsystem. There are really 3 boards that make up the power subsystem. The first one we're going to talk about is called the platform power module. This is your power supply for all intents and purposes. It is auto switching, which means that it can adapt to any voltages worldwide. I don't have the exact numbers. They're around 60 volts to 270 volts. But it basically auto does that, so you plug it into any outlet anywhere worldwide, and it will adapt to that particular power. It provides an isolated AC output for multiple peripherals, and it sets up the environment that makes a safe environment for both the operator and the patients. And why do I mention that? Because it's really important that you use these isolated outputs because many of the hospitals and clinics, particularly OBGYN, they bypass this mechanism by hooking up, for example, a monitor on the wall so that the mom can see her baby as they're doing the scan, and that monitor is plugged into the back of the system and in for video, but then plugged into the wall, the unisolated wall outlet, and that gives it an unsafe path to ground and can cause potential problems. So try to prevent that from happening if you see it occur in your hospital or clinic. It also says that you can put it into sleep mode. Obviously, this is if it has optional batteries, which we'll discuss a little bit more. But these optional batteries give you 20 minutes of life where the system can be in a sleep mode that we described earlier and allow you to transport it from one room to another, from one floor to another. The really nice thing about this is if you're using these batteries, after the 20 minutes, it doesn't just kill the system. It allows the system to go into a orderly shutdown mode or the system will completely shut it down as if it was asked to do so. And the only disadvantage of that is, well, there are two. The next time you start it up, it'll be a full system startup that occurs. And secondly, you have burned all the battery power. So if you're immediately turning it on and in a patient's room, and you want to put it in a standby mode, it probably won't go into that standby mode because, or sleep mode, excuse me, because the batteries have been used up. You're going to have to give them the appropriate amount of time to recharge. You have a power regulator board, and this system DC voltage is 24 volts, and it has a circuitry to monitor the tolerance, 21.6 to 30 volts DC, and if it exceeds those limits, then it simply powers itself down, and your voltage will not it won't allow you to power up. When the power good signal, the 24 volts, is in tolerance, it notifies a channel board that, hey, by the way, you're good to go. You're good to draw any power at that point. It does receive monitored air temp information from the acquisition control board for fan control, and adjusts that voltage, the fan voltage, from 10.2 to 13.8 volts DC to appropriately monitor or cool the system off. It also controls the resident self-test. So if you're having problems with the resident self-test, that resides on the power regulator board. The last portion of the power subsystem is what we call the power distribution board. And it does have some neat things on it, but the one thing that you need to understand is it doesn't have any circuitry on board. And because of that, it really is not a high failure item. It has basically its power from the platform power monitor and distributes them to the connectors I have listed: the solenoid control module, your PCATX connectors, your backplane power cord, and a power connector, excuse me, and your backplane signal connector. So those are just the connectors that it distributes power to, and but really not going to be a high failure item. So let's talk about the front end boards. There's really three boards that set up your front end. Their acquisition control board, and for those of you who have worked on ultrasound or even attend my class, acquisition control board is what we call the front end controller. Every system has a board that accomplishes this. And what's a front end controller? It simply sets up the front end in the appropriate manner for the probe type, the frequency, whatever the operator asks it, selects for the functionality. It tells the front end how to set up. It tells what probe I want selected. So it acts just as it says, front end controller. And that's, if you hear the word acquisition, that should mean front end to you. That means that's where we're acquiring the signal. So acquisition control board, front end controller. The other main function of the acquisition control board is it's the path of communication to what we call the back end, where all the scan conversion's done, all the converting of the information that the front end acquires gets passed to the back end for further manipulation. So acquisition control board. We also have the channel boards, or channel board, excuse me. The channel board, it's a single board. It's responsible for transmit and receive functions. This system, the Epiq 5 and 7, are a 128 channel system. And so when we're talking transmit, we're specifically talking about, this is where the analog signal is introduced. So we're no longer talking digital information, we're talking analog, and we're talking high voltage. So the transmit function is what delivers or generates that high voltage pulse that drives the crystals on the transducer. Then the receive function is where these the echoes strike the crystals on the transducers. Those crystals generate these small or tiny electrical pulses, and so the receive function simply has to take those tiny electrical pulses, it amplifies them, and applies what we call time gain compensation. Time gain compensation is really what the user sets up for it to adjust the amount of amplification based on the depth that they want to look at. What this does is provide a uniform image from top to bottom based on user input. So once it's amplified, time gain compensated, it does what they call digital beamforming, which is in reality analog to digital conversion in what we call summation. It takes these 128 signals that have been digitized and sums it into one large signal that can be passed to the back end. So that's what digital beamforming consists of in general terms. Then we go on to mention that it has a 160 megahertz master clock. And why do I mention this? Master clocks are pretty reliable as a norm. But what I find is if you've done everything, say your system's hesitating, it's freezing, it's shutting down, it's all over the place, unreliable, but it's intermittent. And you've done all the obvious things. You've changed hard drives, you've had new software, you've tried your power supplies, and yet the symptom hasn't changed. It's really a good idea to go find where your master clock is, because as they start to drift, different circuits and different chips will react differently to that clock drift and cause just an amazing array of problems. So it's always a good idea to know where your master clock is. In this case, it's on the channel board. You have your transducer select board, and again, this is what we call the probe interface board. That's where we plug probes into. On the Epiq 5 and 7, we have 4 ports for the standard probes and 1 port for CW, which is continuous wave. One of the primary functions of the transducer select board is probe identification. And why is probe identification? Well, there's 3 places probe identification can get kind of messed up. So if you have a probe and you plug it in and it's not identifying it, the first place you should look is the probe capable of IDing itself? Perhaps a probe got dropped and it damaged the circuitry inside the probe. When that happens, you plug it in and it simply can't ID itself, so you don't get any ID on the screen. The second possibility is, let's say you've taken that probe and put it in a separate port and it still doesn't ID. You've tried another probe. You can start seeing how we can troubleshoot. Is it the probe or is it the transducer select board? Multiple probes, multiple ports. And if you eliminate the fact that it's not the probe, and let's say you ordered a transducer select board and it didn't fix the problem, there's really only one other place it can be, and that's going back to the acquisition control board, because that's what reports the identification of the probe to the back end. So you're really in the front end looking at only 3 possibilities, the probe being the easiest one to eliminate. So now we're moving from the front end where we acquired the signal to the back end where we actually do the scan conversion on it. And we're using standard PCs with Intel chipsets. As I mentioned earlier, the original ones came out with 2 hex core processors in them, and the newer ones have actually gone to 1 processor. And the reason I've heard is because the original ones were released being very, very capable, meaning there are many options turned on, and now they become more specialized. So as you see, if you see Epiq 7G, that's general ultrasound, for example, so it'll have the options turned on for only a general ultrasound. They have a Epiq 7W, which is women's or OBGYN. And then they have an Epiq 7C for cardiac. So they've really specialized them now and taken away some of the need for the 2 processors, or at least that's my understanding. So don't be surprised when you look in there if you don't have two processors. Just talking before on the processors, the other thing I'd like to point out is software started off at 1.1 and has gone through a few revisions, 1.2, 1.3, and just last month 1.4 got released. It's just a software upgrade. It doesn't require any additional hardware updates or anything, but it's good information, so you can see if you're, what level of software you're at to help you identify what generation system you have. It has two standards hard drives, as I said, SATA hard drives for patient data and Cine loops, Cine data. Also, it has one solid-state hard drive, which makes this really unique. It's the first system, ultrasound system out there that has really used a solid-state drive. And this just simply allows it to boot up faster. And when you get in front of one, you'll appreciate just how fast it starts up. It supports up to, it has a graphics card that sets up, that supports 3 graphics heads. One's for the monitor, one is for auxiliary video, and one is for your touch panel and control panel. You have an audio input-output module. And basically, it's kind of in the description. It's the audio source for your continuous wave, your pulse wave, physio, and any beep or bell that the PC wants to chime in on. It also, one important process of this or part of this is it passes on the power on switch signal to the control panel, and we'll show you this in a future slide where you can actually see what the power on signal, the path for it. But it's interesting that it goes through the AIO or audio input output module. So if you are having a problem with the system powering on, you certainly need to be aware that this board's possibly can affect that. It also amplifies the audio signals going to 2 speakers and a subwoofer, so it takes care of that as well. Then we move on to the video input-output module. Again, these I/O boards, if you're facing if you're in back of the system facing the E module and looking inside it, these boards, the input-output boards, are located on the right-hand side of the module. So an important part of this is if you feel like your video input-output module is damaged or needs to be replaced, be aware that it contains the I button, which is a chip. It looks a lot like a battery, and it has the ID of the system, the serial number, and it's associated with the license options that are installed on it. If you place this video input-output module and don't take the chip off the old and put it on the new, your system will be unable to work as an ultrasound. It creates video signals for the 2 S-video outputs and a display port for the additional audio, auxiliary video. And I say it configures the S-video outputs, and what I mean to say in that is that if it's an appropriate resolution, screen resolution for S-video, it will enable them. If the resolution is above what S-video supports, this video input-output module simply disables the S-video outputs. Moving on, we have the extended input-output module, and I mentioned that the acquisition control board is the interface between the front end and back end, and it does that through the extended input-output module. So it acts as a bridge between the front end and back end. It controls the activation of solenoids that lock the control panel. This is an interesting feature on the Epiq. In order to move the control panel up and down, left and right, I'd have to activate the solenoids. And you have to have the solenoid activated, and the only way you can do that is to have your brake pedal fully locked and engaged. If your brake is not on, you will be unable to electrically move your control panel. And I talked earlier that we were going to talk about the power on sequence and the power off sequence. I think this is important because you can't really, or you can't necessarily track the signal from point to point and know where you're losing it, but you at least, if you can follow the signal, you can say what components are affected and start limiting where you're looking. So in the top one, we're talking when we have 5 volt standby. Well, that's when we just simply plug the system into the wall. It's interesting to know that this is one of the few systems that do not have a circuit breaker on your platform power module. So you simply plug it in and there is power to the system. So we see that on the left-hand side of the top box, ACN. At that point, the power module generates 5 volt standby that gets shipped to the power distribution board and split up. One goes to the PC module and one goes through the backplane, through your audio input-output module, which I described earlier, and into your control panel where it's described or illustrated as a white button on your control panel. At that point, moving on to the next box of power supply on, you still have your AC input in there, and what happens is the operator presses the power button, and that signal then goes back through the audio input output module, through the backplane, through your PC module, through the power distribution board, and back into your platform power supply module, and that now gets the power supply on signal and basically engages itself. So now we have the system getting the command to power on. Moving to the next slide, this is what happens then. Now the power supply module has been told to power on. It now generates the system DC voltage, the 24 volts, as well as the ATX voltage. Let's talk about the ATX voltage first. The ATX simply goes through the power distribution board and into the PC module, where it receives the fact that the power supply is okay signal, and saying that I'm in my range, 21 to 30 volts. And when it gets that, the PC module is free to power on. At the same time, the 24 volts DC, the system DC, goes through the power distribution board, and you can see that it generates from there the 12 volts, 5 volts, and 3.3 volts going through the backplane with the power regulator on, and that power regulator on signal goes to the power regulator board, allowing the rest of the system to start powering on. So on the solid state hard drive and the regular hard drives, you have 12 and 5 volts delivered. On the acquisition control board, you have your 12 and your 3.3 logic voltages delivered. And then, as you can see, the audio input output gets your 24 volts as well as your 12 volts, 5 volts, and 3.3 volts. At that point, if you move back up above that to the power regulator board, it simply goes to the acquisition module, which is your front end, and powers the front end up. So that's your power on sequence. As you can see, it's just not that difficult. There are not a ton of different voltages going on, and the signal flow is pretty straightforward. So pretty nice system to work on, and we will get into some troubleshooting techniques for the power supplies. Then moving down to the last box, we're simply talking about how the system powers down. Well, you, as an operator on the control panel, touch the button. It sends a signal to the PC module saying, let's begin an orderly shutdown. The PC module begins that shutdown, and once it's safely shut down the software, it sends a signal to the power distribution board and then subsequently to the power supply, and the power supply just removes all needed voltages with the exception of the 5 volt standby that will still be present. All right, so that's our Epiq power on sequence. Let's talk about troubleshooting now. Troubleshooting, this is kind of the meat and potatoes. This is what we're probably all waiting for. How can I fix the Epiq if it's broken? And so let's talk about some tips that we can give you. So let's start with the power issues. let's say you step in front of your system and it's running, or not, the white light's present, and you go to press the button, but nothing happens. The system doesn't power on. So what we're going to try to do is talk about a series of steps that we can do to isolate the power problem, or the problem that's not allowing it to come on. So if the power does not come on, then in all likelihood you have a problem with your AIO, which is your audio input-output module, your control panel, or the cabling. Now the way you can kind of isolate that is by going to these two switches located on your motherboard or backplane. I have them marked power on and reset. You simply use the power on button, and if the system powers on, then we know the system's good. So now we're just trying to go one step further and figure out what's going on. So as we move to the next slide, we're talking about how we isolate that. You can see the cable that I have there. This is a DC power cable that's connected to the control panel, or connects the control panel with the audio input-output module. You simply unplug that and go back to your backplane and press that button as I illustrated, and you know if it starts up that you surely know that it's the AIO, the power cable, or the control panel, and you can start troubleshooting from there subsequently. So it makes it's a really easy troubleshooting technique to try to eliminate the control panel or the power cable. One thing on the previous slide I did show you was a reset button. I do caution if you have to reset the system and you're in that, you have the E module opened up, it's as safe a way to reset the system as unplugging the system from the wall, meaning it's just not a recommended practice. But if you have no other way of shutting it down with the exception of pulling the plug out of the wall, this gives you an alternate solution. So be careful using that, because you run the risk of damaging the hard drive and the software. So on the back of the system, on your platform power module, again, you'll see some reference to the Voyager platform power module. You have 4 lights, 4 LEDs, and so I'm going to describe them. Number 1 is your AC power present. That simply means your system is plugged into the wall. Now I know I have an arrow there with the number 1, and I'm not sure you can even see the green light there. It is very, very difficult to see that light. You basically have to get down low and get the right angle to visualize that light. But it is there, or if it isn't there, it means you're not getting AC power to the power supply module. You also have the battery status light, and I have the table listed below, beside it, excuse me, and it simply shows that if the LED is off, the AC is not present, battery not present, or the battery system's not enabled. So it does matter if you have or don't have battery option installed. And then we talk about the blinking lights and solid yellows and blinking green. I just want you to realize that these are only happening if you have batteries in them. They aren't always, the systems aren't sold with a battery option on all systems. And a side note to that, while we're talking about the batteries, is if the system is shipped to you, if it's brand new, you probably won't have to worry about it because it's being installed by Philips. But if it's not brand new and you're getting it shipped to, say, a separate facility, there are 2 batteries in it, and they should be taken out and put upside down and put back in the slots located at the bottom there. You can see the slot right there. There are 2 batteries, 2 slots, but they should not be remain engaged. So they simply tell you to pull them out, turn them upside down, and put them back in during shipment. Also, if you're replacing the batteries, be sure that you replace them as a pair. That's right out of the manuals, and it's a really important concept. Don't replace one without replacing the other. Then we move on to the third light, which is your 24 volts DC is ready. The system power does not have to be on necessarily. This light can be on with a power in the off state. It's simply saying I do have 24 volts. It is in my range. I'm ready to go when you are. As soon as you press the button, then number 4 will happen. Your ATX power will become available, and that light will go on. So those are your indications from the back of it on the platform power module. I think they're very useful. Just be careful with the battery one on knowing whether you do or do not have the battery option enabled. Additional troubleshooting tools. We have the several sets of LEDs that I'm going to describe here. We have LEDs on the power regulator board. There are several different types of regulator boards. This is one that's fairly common. And as soon as you turn on the system, you'll see the image on the left. You'll get the 2 green lights. Some of them will also have the light just above the 24-volt one on top will also flash on. Not all of them do that. But keep in mind that those are momentary lights. They don't stay on for very long. Immediately after that, they go to the right-hand slide, which is the normal state. And there's no way to know what symptom would be caused by having one of these LEDs out, but you can clearly see that they're marked 12 volts, 5 volts. So it will give you a clear indication of what the fault is, even if you don't know what the system's going to react like. Then we go on to the acquisition control board. And this, keep in mind, I'm going to show you a video on the next slide, so you'll see a little bit more how this actually looks in real time. But you have your neon core voltage to channel board. Those are clearly identified at the top. You have your acquisition control board logic voltages. Then you have your 12 and 3.3 voltages that are delivered there, and it'll tell you whether you're getting those. And then you have your argon configuration. Argon is circuitry that has to do with delivering the high voltage pulse. Then you have your xenon, and this is happening at the splash screen. These stay constant after the splash screen. So, and you'll see this in a video on the following slide. And the BP cell, I will describe on the following slide, so you get an understanding of what's going on with those lights. They are not in this. This is not always in the off position. And then we have our the bottom set, the bottom 4. It says argon on them, and basically it's in a runway state. They'll be rotating, and you'll see this in the next video. And that means they're happy. It's only if it's not doing the runway strobe effect that they're not happy. So here's the video I was describing. And really what I want you to concentrate are the 2 sets of 4 red lights. The bottom one is clearly happy. It's doing the runway just like we described. And then the top one, you're going to see this is a looping video. So you're going to see the top 3. These are labeled 0, 1, 2, and 3. So there are 4 lights labeled 0 to 3. And 0 will only be on during initial startup. And it's saying that the card cages and the front and the back end are communicating to each other. The second light, or light number 1, you can see is only on when it's actively scanning. So you can see in this video here that it comes on and off. And once it gets to the fully booted in imaging mode, if it's not frozen, if it's actively scanning, that light will be solid as it just was. And the blinking light is the light number 2. Again, remember 0, 1, 2. The light number 2 is blinking at all times, and that means it's in a happy state. It likes where it's at. The bottom light is the one that you never want to see on, and that means there is an error. And at that point, you'll need to be troubleshooting what's going on with the acquisition control board. So the last light is the one that you should not see after boot up. This is LEDs that are located on the channel board. Again, one of the things that are difficult about these LEDs, They're located on the left-hand side of the system as you're facing the front of the system, and they're very difficult to see because they just have a really small area into which to see them. They say you might need to use a mirror or some kind of reflective device so that you can easily see these lights. I use my camera, my camera phone, because it will fit in that slot, and I can get a much better view of what I'm looking at. It's important to know that the two on the left-hand side, the two banks on the left-hand side, are identical. They should look and react exactly the same way. And the one on the right-hand side should clearly stay all green. Again, very difficult to get a clear view of it, but there it is, and it is a useful tool. So to finish up with, one of the things we can use to help us isolate a problem if the system won't turn on and completely boot is we can try to go into what they call minimum configuration. And in reality, what I would do is just as simply a test to try to isolate specific components from causing a problem. So on the right-hand column, this is the minimum test environment. That's what MTE stands for. Minimum test environment means that you can remove the boards from what EIO, the extended input-output board, down. You can remove those boards from the system, and the system should still boot to a minimum test environment, giving you an indication that it's one of the boards that you removed is causing the problem, is holding the system down. If at that point it's still not working and still not getting into a minimum test environment, you can clearly turn it into simply a PC, meaning that you have your software, your operating system software and application software located on your solid-state hard drive. You have a power supply for it that generates your ATX power. So you can turn it into simply a PC and see if that's holding it down. And at that point, if it boots up, you know that it's one of the remaining cards that you just pulled out, the audio input-output, your LCD, your graphics cards. One of those boards is holding the system down. So a good way to eliminate some of the boards if the system's simply not booting completely the imaging. And that's what I have, so I'll turn it back over to John.
Fantastic. Thanks, Jim. Great presentation. We do have a bunch of questions here, so we're going to get right to them. The first one, you mentioned the importance of PMs to prevent system failures. What is a recommended interval for PMs?
The OEM in this case says that the system should be PM'd every 12 months. I'd just like to add that there are several accreditations, American College of Radiology, that require the PM to be performed twice a year. So it really is OEM 12 months, but you have to look at your accreditation if any.
Okay, great. I want to before the next question, make a quick announcement. A lot of people are asking about the downloadable versions of the slides. This recorded webinar will be up on onetechnation.com/webinars by tomorrow. Give us 24 hours so you can look at the recording of this entire presentation at onetechnation.com/webinars. Okay, next question, Jim. How do you reload system software?
That's an interesting question. For the Epiq, this is brand new to most new systems or modern systems. You can't reload software on the Epiq. They have locked that out, and that gets into kind of where I opened up, where we have the right to repair. In this case, they don't sell the system software with the system, and even their service engineers have to download the software on a case-by-case basis to be able to reload software onto the system.
All right, moving on. How can you protect the system from a software or hard drive failure?
Well, that's where that's one of the things that we absolutely recommend. Since in this case you can't download software and reload it onto the system, what we recommend, and we highly recommend it, strongly recommend it, is to go ahead and make a digital image of your hard drive, a bit-for-bit image, if you will, and have that located in a safe spot, so that if your hard drive does fail, if their software does get corrupted, you're simply able to plug in a hard drive, a digital copy of your hard drive, and bring your system right back up to a functional state.
Next question. What size are the hard drives again?
They're not locked to a size because they're SATAs. We normally recommend 500 megabytes because you don't have any gigabytes, excuse me, because there are no limitations that way. You don't have to have variable sizes, one size fits all. SATA being what it is today, there's, you can go up to a terabyte hard drive, which can be used in basically any ultrasound system out there.
Next question. Are there any error code access on the system? Or is there any error code access on the system?
No, we have the ability to run a system confidence test, if you will, meaning that we can run a version of diagnostics. However, that version does not give us, it's a pass or fail ending to it, so it doesn't tell you specifically error codes. If the system is kicking an error code, there is no way without an access, Phillips access, to be able to go in and run any specific diagnostics against an error code at this time.
Next question. Does the system need to be on for the battery to recharge?
The system does need to be plugged in, yes. The power supply has to be active, but other than that, it does not have to be on as far as a full imaging mode state.
All right. What was the latest software version?
1.4 just got released last month. I believe it was last month. It's very recent. It did not require any hardware updates. It's simply a software update. It is backwards. In other words, 1.3 systems will be able to run 1.4 software. So 1.4.
All right, next one. Have you heard of overheating probes?
That's an interesting question. Yes, probes can overheat. There are basically two types of probes that we run into in ultrasound that do overheat. One is what they call a TEE probe associated with cardiac systems, that transesophageal, and they are closely monitored. And one of the reasons that they overheat is that they even they're not actively using the TE probe, they are not freezing it, so the probe continues to transmit and builds up heat over time. So a good practice is to try to educate the staff on freezing them when they're not actively scanning with it. Will prevent it. The other type of probe that can overheat, or you can feel a temperature increase on, is a phased array probe. And you can feel the face get warm. These should never be hot. They should not even become close to uncomfortably hot. But you will feel a temperature difference between room temperature and the face of the probe. But those are also closely monitored, and if the system senses that they're pulling too much power or that they're overheating, it will suspend scanning.
Okay, kind of a big general question. What's the main difference between the Epiq 5 and Epiq 7?
It's basically you have the standard model of a car. You go out and you purchase, and it doesn't have any bells and whistles on it, or you can upgrade and get the sunroof and air conditioning and power windows and door locks and alarms. It's a more expensive system that has more bells and whistles associated with it, and so it is a slightly upgraded model, if you will.
Okay, that's going to do it for the Q&A portion. There are several questions that did not get answered. Attendees, please don't worry. Those are going to be forwarded on to Conquest and Jim and his team, and they're going to be more than happy to respond to each and every one of your questions in a timely manner. Is that correct, Jim?
Absolutely.
Wonderful, wonderful. So great participation today. Fantastic questions, good dialogue. I wanted to thank again Conquest Imaging for sponsoring today's webinar. Our presenter, Jim, thank you again for great presentation. Please visit them at conquestimaging.com to learn more about their products and services. And attendees, remember, to obtain your certificate of attendance, you must complete the post-webinar survey that's going to appear shortly on your computer screen. If you do not receive the survey, you can email us at webinar@mdpublishing.com. Please visit onetechnation.com/webinars and register for our next webinar Wednesday. Thank you all, and have a great rest of the day.